Okay, what we want to do is talk about our Common Core is functions. So it's F1F, so it's describing functions, and what we want is functions domain, and specifically today we're going to talk about piecewise graphs, okay? Alright, little side things on the side note. Okay, let's make sure we know this. One, don't divide by 0. Okay, don't divide by 0. And second thing is can't have a square root of a negative number, okay? Okay, so those are two important side notes, okay? One, don't divide by 0, ever. What is 0 divided by 0? If you have it here, if you haven't heard this, it's pretty good. Yeah, listen quietly.
Imagine that you have 0 cookies and you split them equally among 0 friends. How many cookies does each person get? See, it doesn't make sense. And Cookie Monster is sad that there are no cookies. You are sad that you have no friends.
Don't divide by 0. Divide by 0. You're going to make Cookie Monster very unhappy.
And you don't have friends.
Doesn't make sense.
Right? You're sad. Cookie Monster's sad. So don't divide by 0, okay? Even on your calculator, we can go ahead and take a look at it. We can go on. We can go like 1 divided by 0. You get a domain error, okay? You cannot divide by 0. Okay? So we need to know that. You cannot divide by 0. Even Cookie Monster agrees you cannot divide by 0, okay? And the other one is the square root of a negative number. Clear. If we went square root of, say, -1, you know it's non-real, okay? So as we talk about domain today, we need to go ahead and consider that, all right? So, question number 8, find the domain. So, as it exists, most of the graphs that we have been graphing in Algebra 2 just flow along really nicely. We haven't worried about domain a whole lot because we've just been graphing and all the numbers work. All the numbers. When we start to look at problems like this, where you have fractions or square roots, we're going to have a problem, okay? So first of all, in a fraction, there's a possibility of having a problem of 0. So I'm going to rewrite A, and I'll rewrite as 1 over x times x minus 1, okay, because there's a 1 there, okay? And I want to write it like that because it becomes a little bit easier to see what x cannot be. So I just took the first expression, and I common factored out the x. Both have an x in common, so I put the x here. And what would be left is an x minus 1. Okay, everybody all right with that? If you're not sure, you can go ahead and rewrite as x squared minus 1x, right? Now, when I look at that, and I go back to this whole thing about don't divide by 0, what I know, first of all, is that if x did equal 0 here, if x were 0, I'd have 0 times this, which is 0, right? So right off the bat, I know that x cannot equal 0, because if x is 0 in this expression, you'll divide by 0. That's bad. X also can't be 1. Because if it's 1 right here, I got 1 minus 1. Does that make sense? 1 minus 1 is 0. So x cannot equal 1. Those are the two restrictions. X cannot equal 0 and x cannot equal 1. I got notes right here, guys, for you. So, what's our domain? Our domain is, believe it or not, everything. All real numbers except those two. So the domain in this case is going to be domain x equals all real numbers except x cannot equal 0 and x cannot equal 1. That's the domain for the first function. Can't divide by 0. If x is 0, you'd have it divided by 0, and if x is 1, you divide by 0, okay? Think about it. 0 minus 0 is 0, you're in trouble. 1 minus 1 is 0, you're in trouble, okay? That's what x cannot. So when you have a fraction, you've got to look at saying, okay, what is going to cause me to divide by 0? What values will make me divide by 0? And you have to think about it, okay? Okay, B. I've got this square root of 9 minus x squared. So I've got to think a little bit about this. I'm going to show you a couple of ways to do these too. 1, let's think. Can x be 3? Can x be 3? Okay, 9 minus, what's 3 squared? What's 3 squared? Okay, so what's 9 minus 9? And you can take the square root of 0. You can. So x can equal 3. Can x equal 4? Can x equal 4? Think about it. Can x be 4? Because you'd be left with the square root of 9 minus 16, which would be a negative number, right? So x cannot equal 4, right? How about negative 3? Can x equal negative 3? You can, because negative 3 squared is a positive 3. 9 minus 9 is 0, so it can equal. So x can equal negative 3. What about negative 4? No, so it can't equal negative 4 either, okay? So it seems like this graph is in between negative 3 and 3, right? And turns out it is. The domain of this function turns out to be this. Negative 3 to 3, okay? In interval notation. Now, if you have a hard time doing that, another way you can do it, remember we talked about it visually. Domain is how wide the graph is, right? What's the width? So what if we could see it? Maybe that would help, okay? So first of all, let me graph the first one. F of x, hold on, I'm in the wrong mode. Go back and get into functions. Okay, y equals, clear. Let me graph the first one. 1 divided by parentheses, x squared minus x. Let me graph this first equation, okay? Okay, what do you notice at 0? Do you notice anything weird happening at 0? It's shooting off to infinity. It really is. And at 1, as it approaches 1, it's shooting off to infinity. So your graph just shows it. You could go to your trace button. Check it out. Go to your trace button. Oh, 0. What's the y value? There is none. I went to trace 0. What's the y value? There is no y value. X cannot equal 0. Try trace 1. What's the y value? There is no y value. It's because x cannot equal 1, all right? Now look at the next one, okay? Same graph, y equals, clear, square root, 9 minus x squared, parentheses. What's my window? Oh, that'll work. Let me go a little higher on my y. Let's go 4. Okay, graph. Okay, what's it look like? Looks like a half circle, right? And again, we talked about domain. How wide? Remember, how wide is your graph? This graph goes from negative 3 to 3. That's another way to do it. If you can graph it. Do you see the graph doesn't exist over here on the negatives? It doesn't exist over here, but it does exist from, you ready? Negative 3 to 3. And that's what we put for an answer, from negative 3 to 3. Okay? Now, how about this next one? This one's a little tricky because we've got two things we have to worry about. We got to worry about the fact that we can't divide by 0. And we got to worry about the fact that we can't have this thing be negative, okay? So, if t were negative 1, is that going to cause a problem? Well, let's think. T equals negative 1. Well, negative 1 plus 1 is 0. Square root of 0 is fine. Square root of 0 is 0, but you can't divide by 0. So t cannot equal negative 1, right? But it can equal everything bigger than that. So the domain on this one is, it's going to be t is greater than negative 1. Can't equal negative 1, but from negative 1. Or in interval notation, you can draw it like this, negative 1 comma infinity, parentheses. You always use a parentheses with infinity because you can't get to infinity, right? Right? Yeah, it's easy to draw the sideways 8. I do that all the time too, okay? So another thing, okay, so let's say you're confused. You're having a hard time with this stuff. Let's graph it, okay? Really having a hard time seeing this because, you know, I've been doing math forever and you haven't. But can we graph it? Sure. Let's check it out. Let's put this graph in. We're going to go x divided by parentheses. Actually, I don't know if I need the parentheses. Square root of x plus 1. Let me graph this, okay? All right. So it looks like this, right? So let's go to trace, and let's go negative 1. What's my y value?
There is none.
There isn't one. But I can move along, and I get y values as I continue getting bigger and bigger and bigger on the x's, right? So there are other x values that make up the domain, but you can't have it beyond negative 1. Because if I go beyond negative 1, I'm going beyond negative 1. It's no y values, see? No y values. Nothing, nothing, nothing. Okay? All right. So, domain range. Most graphs, it's everything, all real numbers. Most graphs, nice, cool graph, it's everything. But when you divide by 0 with an x value, you've got to be careful. When you take the square root of negatives, you have to be careful, okay? Those are the times you have to worry. Okay, example 2. Okay, this is a piecewise graph. So yesterday I kind of drew a thing like this, right? We need that type of graph to be here, okay? There's some tricks to doing piecewise graphs. First of all, we know that they're done in pieces, okay? So here's what we're going to do. These are my boundary lines, okay? These are my boundary lines. They're not really part of the graph. I'm going to put my boundaries lines in with a highlighter. They're not really part of the graph at all, but I like to put them in because it helps me, okay? So I'm going to have a boundary line between -4 on the x's. These are x's, x-axis, right? So -4, 1, 2, 3, 4. So I'm just going to draw a boundary line, okay? And -1, and 2, and 5. Okay? I'm going to have 3 graphs, 3 different graphs, 3 pieces of this graph, and I'm going to have them in between these boundaries, okay? So I'm going to have 3 different pieces. I'm going to have a piece in here, I'm going to have another piece in here, and another piece in here, okay? So how do we do it? Duncan, I know you're wide awake. Of course you are. There you go. So first of all, the first graph, f of x and y are kind of the same thing. We talked about that yesterday, right? So instead of writing fx, let's just write y. Y equals -3. That'll be graph 1. Y equals -3. So I got that. f of x is y. Y equals -3. So how do I graph y equals -3? Anybody remember? What's the graph y equal 3 look like? Anybody remember?
Don't you just go straight down 3 and then it's off?
Nice job, Wyatt. You remember that. And that's been a year since you've had math.
Yeah.
Way to go. Wyatt's totally right. Y equals 3 looks like, and use pencil please, use pencil, or just wait if you use a pen. 1, 2, 3, -3 goes all the way across like that, okay? That is totally correct. Nice job, Wyatt. However, we don't want all that graph. We only want a piece of it, okay? What piece we want? We want the piece that's only in this region. We want the piece that's in between -4 and -1. So we only want this piece right here. We all erase all the rest. So y equals 3 goes all the way across. But what piece we want? We only want the piece between -4 and 1. So we erase all the rest, okay? Get rid of all the rest of this, okay? So there's my graph, y equals 3, but I only want this part of it right there, okay? How's that? Now let's look at the next graph. So f x and y are the same thing. So I've got a y equals a x squared minus 4, okay? That's my second graph. Now that's a parabola. Remember, x squared, that's a parabola. And we're going to go start at -4. So I'm going to go down and put a dot at -4. So I'm going to go, okay, 1, 2, 3, 4. Yeah, and the way I knew a parabola is they're squared numbers. You guys agree? X squared, they're just squared numbers. So if I go over 1, 1 squared is 1. Over 1 squared is 1. Go over 2 squared is 4. 1, 2, 3, 4. And so it's symmetrical. 3 squared is 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm wasting my time though, aren't I? Because I'm going to erase this part of the graph. You guys agree with that? So I'm just going to draw it in lightly. So here's my parabola. It looks something like this, okay? But I don't want all of that, right? I'm going to erase a whole bunch of that. Because I only want what piece of this. So here's my parabola. I only want my parabola between -1 and 2, right? So I only want this parabola right within this region here, okay? Between -1 and 2. So I only want it right in there. So I'm going to erase all of the rest of this parabola. In fact, the problem is even if I left it right now, I'd have a problem with things being a function, right? Wouldn't be a function right here. I have to erase it. Cannot have this, it wouldn't be a function. It says f of x. If it says f of x, it's got to be a function. Can't be, so I have to get rid of it. Absolutely have to get rid of this part right there and there, okay? Right? How am I doing, okay? Now the last graph, the third graph, is like y equals an x minus 2. Well, to graph that, I would go down to -2 and put a point, and I know that's like a 1 over 1, so I'd go up 1 over 1, up 1 over 1, so the graph would look something like this, right? But of course I don't want all of that either, right? So that's the whole line, start at -2, up 1 over 1, up 1 over 1, but obviously I want the graph only between 2 and 5, so I only want this piece here. So I erase all of that, okay? Now, I'm going to do one last thing. I want to show this with you. I'm going to put an open dot right there. All right. Okay, smart kids. Why is there an open dot right there?
Because there could be more.
What do you see right there? What do you see right there? Does it equal 5? No. So right at 5, I don't let it be equal. Now there's a couple of places where it's not equal. It's not equal at -1, but then it is, right? It's not equal at 2, but then it is. That makes sense? So you got an open circle, but then you fill it. You got an open circle at -1, but then you fill it. But at 5 at the very end, there's no way to fill that. Okay, now what about domain and range of this thing? So what about domain? What if we have to do a domain of this graph? Okay, this graph exists between here. How wide is it between here and here? Right? So the domain exists. What's its very furthest back x value? 1, 2, 3, 4, right? Does it equal 4? It does equal 4. In fact, it says it equals -4 right there, doesn't it? So we can put a solid dot there. It does equal -4, right? So we go bracket -4, comma. How far over does it go? 1, 2, 3, 4, 5, right? Does it equal 5?
No.
So put a parentheses. Getting it? Okay. How about range? How about range? Reach for your range, okay? Range is up and down. Reach for your range, okay? What's the lowest y value? Yeah, 1, 2, 3, 4, and it does equal -4. It does equal -4. Yeah, and what's the highest y value? +3. Does it equal +3? Parentheses. There you go. Can you do that on a quiz? Okay. All right. Ready to turn the page? Okay, example 3. Now, so there are 2 ways to do example 3. Okay? One, guys, there's 2 ways to do example 3. One is to graph it like we did over here. We could graph it, okay? But we're not asked to graph it. All we're asked to do is plug it in, okay? So let's just plug it in. I gotta know where to plug it in, okay? So f of -5. So let's think about this. F of -5. Which graph, which of these 3, the first, we'll say it's first, second, or third, where would I plug -5? First, second, or third? Look at this. Look at this. Where would I plug it in? The first. Is -5 less than 0? That's where I would want to put it, is into this function. So the 3x is used for every x value less than 0. Okay, is -5 less? Sure it is. So to find that, we're going to plug the -5 into here. We're just going to go 3 times -5, which is -15. F of 0. First or second or third graph? You sure? I'm sure it's the second. How do I know it's the second?
One of the points up there is 0.
It says it equals 0. So it's going to be x is greater than or equal to 0. So it's got to go here, right? Do you agree with that? So it's going to go into that one there. Not into this one because this one doesn't equal 0, right? This is just less than 0, but equals 0. So plug it into the first one. Or second one. I'm sorry, second one. 0 plus 1 is 1, okay? 2. Where's the 2 go into?
It's the third one.
Nope, it's not.
Second?
It's the second one. Why? Why is it going in the second one?
Oh, it's greater than.
Do you see the equal? Equals 2, doesn't it? This one's greater than 2. This one's equal to 2, so you plug it into the second one, right? So this one's going to go into there. So I'm going to go just a 2 plus 1, which is 3, okay? And finally, the 5. Now that's easy. Where's the 5 going to?
There was 3.
You guys agree? I mean, 5 is greater than 2, so it's got to go into the last one in the third equation. So it's just going to be a 5 minus 2 squared, 3 squared, which is 9. Now, real quick, I'm going to graph it. I just want you to watch. It will take me no more than a couple of minutes to graph it because I'm pretty good at this stuff. So if I graph this, let's see if all of this makes sense visually, okay? So if I had to graph a 3x, I'd go start at 0, up 3 over 1, up 3 over 1. Just watch. You don't need to do this, but I want to show it to you, okay? Okay, I'm going to erase all of this part of the graph and put an open dot there, okay? So here it is. Okay? X plus 1, I'm going to start at 1. I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. That's this graph. But I'm only have between 0 and 2. So I'm only going to keep this part of the graph. Solid dot because of the equal sign. Solid dot because of the equals 0 equals 2, okay? This one, let's see, at 2, it's going to look like this. You don't need to know 1, 2, 3, 4. You just have to believe me that it looks like this. Okay, it looks like this. And then, let's see, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. I'm going to erase all of this. The graph looks like this, okay? All right? Okay, this is our graph. It really is. This is our graph. Okay, you guys see it? So let's go back to the original question, okay? So here we go. -5, f of -5. So if I go back to 1, 2, 3, 4, 5, what's the height? It'd be way down at -15. Do you believe me? Okay, let's look at f of 0. So at 0, is my answer here at this open circle? Heck no. My answer's right there, isn't it? At 1. Okay. F of 2, let's go to 1, 2. Is my answer here at this open circle, or is it up here at this dot? Which would be at 3, and guess what we got? F of 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. And guess what we got? 9. What do you prefer, though? Probably not graphing it, don't you? Okay, so that is the lesson. Homework is page 156, 33, 55.